Today we are going to be working with a balance scale. This is a hands-on tool that helps kids to learn about how to solve algebraic equations that have a variable in them. This equation just has one variable. I found this little applet online and I wanted to go ahead and try to use it to kind of see how I could incorporate technology. So here we go. This equation says 3x plus 1 equals x plus 3, so in order to represent that, I have to drag out 3 x's on one side. The equal sign is like the balance beam. It's like how this is represented right there. So this side is on one part, and then this side is on the other part. Add one to that side. And I really like this applet tool because of how it helps you solve it once you get it set up on the balance beam. So say maybe I didn't do it right, it says the two sides don't match the equation. So it kind of tells the students that they don't have it quite right yet. Now you can see how it balanced out because the two sides of the equation are balanced the way it is supposed to be. Alright, so from here, the applet's going to kind of, let me know how to solve it. So here it's asking if I need to add, subtract, times, or divide to both sides. So as a student, I might see that, I can take away 1 from each side. And I can see how I could take away x from one side as well. So I can put in x. Okay, so now it has 2x equals 2, so I can see that if I divide by 2, it'll kind of x plus 1. See, now I have that done. So it'll load a new problem for us, and you can set that up and continue that as well. So I have gone into the negative applet, and this shows me that I have negative 2x plus 3 equals x. So it's the same thing. You click and drag the quantities from the bins to balance the beam pan so that you can represent the equation. So I am going to need negative 2x plus 3 equals x. And then it does the same thing as the other applet, which is something I actually really appreciate about the applet because it shows how to write down each step of the equation, solving it with mathematical terms instead of using the application or the hands-on manipulative. So for this one, it's a little more tricky because, of course, there's that negative 2x plus 3x. So you have to kind of figure out what your first step is. Okay, so the first thing I did was I minus x from one side, and now I can see that I could subtract 3 from both sides. So I'm going to go ahead and do that. Okay, and now I see that I can divide by negative 3. So let's see, I have to make sure I enter in that negative 3. Oh, see, I have x equals 1. So that's kind of another version of this applet that's really awesome and cool, and it represents those equations for kids. The only thing these applets don't do is they don't use 2 variables. They just use 1 variable, and so that's something that's kind of different. They do have it for different ages, but I haven't found it to use 2 variables. So there's with negatives as well. Okay, so I went to the older age group. I went to the 9th graders or whatever, but it shows that it has 2 variables on each side. I'm going to go ahead and do one with a variable on each side just because it shows more of how you need to use the manipulative, keeping the balance beams even by doing each thing to each side. So I'm going to go ahead and set up my equation. Okay, now that I have my equation set up, I can go ahead and check it. It went through, and now I can start doing my math. So I see that I can subtract 1 from both sides. Of the equation, I'm seeing that I could take away 2 x's. And then I have x equals 3. So that one's pretty easy too. Again, I like how it shows all of that. I'm going to go ahead and go to a different one now that is a lot easier for showing the distributive properties and multiplication, because this one doesn't allow you to do that. It says that you have to enter the equation in the form of a of x plus b equals c of x plus d. So kind of a little bit of a stipulation there. Definitely have to be working with very basic linear equations. So, or not linear equations, but algebraic equations.
The core?
Okay, so something that I have found as well as this algebra tile one, you put your equations in here and then you can do your products in here. I find this one a little bit more confusing for students. I don't feel like they can as easily solve for what x is or solve for what y is, but it is really great, especially if you are using parentheses. For example, if you have 3 parentheses, 5x, then you know that they need to represent 5x 3 times. So that's kind of something that is a little bit easier to do. They don't necessarily have a parentheses button, but it's kind of something that you can infer as a teacher. If there's a parentheses in that equation, then how many times are you going to have to represent it? Well, obviously you're going to have to represent it 3 times. So yeah, the great thing about this manipulative is they're very easy to move around. You can adjust how large your x is, or how big your y is, or how small, and that's really kind of cool, I think. It kind of allows you to easier see what it might represent. So, something to think about. All right. So if we had 5x 3 times, you can see how that's represented. Yes, this applet isn't very good for solving equations, so it's something I'm kind of learning as I'm messing around with it. But I do feel like it is a little bit easier to show harder equations or distributive equations. So that's something that's kind of cool about it. Alright. Okay, this is more of like an Algebrock tile mat. This balance here represents the equal sign, and then this is positive, negative, positive, negative. Our equation is right here. It's the 2 parentheses x plus 3 equals 4x minus 6. You can see how these actually positive 6, negative 6 on this side. So what you want to do is get all your x's on one side. So you can see here that you can take away 2x from each side. Now to represent that on here, you would add a negative 2x onto this side, negative 2x on this side, and they would create a 0 balance, and then you can just take them off. Since we know that, we can just move them off to the side here. Alright, and that leaves positive 6 on this side, positive 2x on this side, and negative 6 on this side. Now, we can add positive 6 to this side and take away negative 6 on this side. That keeps each side balanced, but however, you're still continuing the equation. So since I know that, I would be taking them away on. So because I'm adding 6 to this side, I have to add 6 to this side. So I'm adding 6 in the positive, which means I add 6 in the positive on this side. So I can really just take these and put them over here. And I think you can see now that what the equation represents is really x equals. Hold on. Okay, so you can see I have the 2x and then I have 12 on this side. So you can see that x will equal 6.